So, have you ever wondered what the sum of all the angles inside a triangle is? Lewis, can you inform us what the sum of all those angles must be? 180 degrees.
That was my next guess.
So, you don't have to take my word for it because I will prove it for you. All right. So, this is a proof of the triangle angle sum theorem. Why and how we know the sum of all the angles in a triangle must equal 180 degrees. All right, so first, this is how many proofs start. We're going to just draw a triangle. So we start with just our triangle. Statement. Reason. So what we're given is simple triangle ABC. And our reason, that's what we are given. So, I can draw a line that's parallel to that bottom of the triangle AC through point B. We learned that way back at the beginning of this chapter. If I have a line and a point not on the line, there exists only one possible line that's parallel to that line and goes through that point. That's called our parallel postulate. So I can go ahead and say draw line PR through point B and parallel to side AC. We called that our parallel postulate. And something obvious, given. All right, so notice above, when I drew that line in there, I now have three angles. Angles 1, 2, and 3. Those angles form a straight line. What has to be the sum of all three of those angles? 180 degrees, right? So, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Angles that form a line sum to 180. Right? We're not going to see linear pairs because there's three of them, right? There's actually three angles, so I can't say linear pairs. All right. Let's go back up to our figure and take a look again. So these are parallel. And if I extend this down and extend this down and extend this out, okay, what type of angles are angles 1 and angle A? Are they on the inside of those parallel lines? And they're on alternate sides. So what type of angles are they?
Alternate interior.
Alternate interior angles. Now, we know alternate interior angles are congruent if those lines are parallel, and that's the type I drew. Don't we know the same thing about angle 3 and angle C? Those guys are also alternate interior angles and must be congruent since those lines are parallel. So now, I'm going to state that angle 1 is congruent to angle A, and angle 3 is congruent to angle C. And that's our alternate interior angles theorem. Or alternate interior angles. I'm not quite ready, though, to substitute those in. Yeah. The idea is I want to substitute these in here so I can show that the sum of those three angles in the triangle equal 180. So I need to go ahead and make sure they match perfectly. I know congruent angles, the definition of congruent says they have the same measure. The measure of angle 1 equals the measure of angle A, and the measure of angle 3 equals the measure of angle C. That's just our definition of congruence. Congruent angles have an equal measure. All right, and we are almost there. Now what I can do is take this measure of angle 1 and substitute the measure of angle A, and take this measure of angle 3 here and substitute the measure of angle C. So I end up with what I was attempting to prove, the measure of angle A plus the measure of angle 2 plus the measure of angle C, all equal 180 degrees.
Yeah.
No, I'm substituting it. So I'm for 3, I'm substituting in C, so I can deal with that triangle up above. We'll take a look in just a second. Substitution. What I did, I took this original one, that one we created with the line, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, and I found a way to substitute those angles for the triangle. So if we look up here now at our triangle, what we showed is angle 2 plus angle A plus angle C, all summed to equal 180 degrees. So now that I've proved to you that the angles in a triangle sum to equal 180 degrees, let's go ahead and use it. You try example 1. See if you can find those missing angles. All right, so we want to find this missing angle here, and I know they sum to 180 degrees, so I can simply set up an equation that looks like this. The sum of the three angles equals 180, and then I solve. So x plus 97 equals 180. Subtract 97, x equals 23. Easy enough. Next one. Whenever I have a right triangle, what is the sum of the two acute angles in that right triangle? So I have a right triangle. I have two acute angles. So those always have to sum to equal 90. The acute angles in a right triangle are always complementary. Since one angle takes up 90, the other two have to be 90. So we can say 2x plus x equals 90. 3x equals 90. X equals 30. So that's 30. And that's going to be 60 degrees. That's a special triangle, which we will go ahead and investigate further in the second semester. So it turns out that, not sadly, I don't have the time this year to prove every single theorem in geometry. Right? So if when I present a theorem without a proof, you want to see a proof for it, you're welcome to see me after class or at lunch, and we can write up some sort of proof to go ahead and prove the theorem if you don't want to take my word. Huh? But here's a theorem just that. Right? The sum of an exterior angle of a triangle is equal, actually, not the sum, the measure, let's correct that, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So let's go ahead and take that apart and see what it looks like. So this is an exterior angle. An exterior angle is, if I go ahead and continue out a side, we create an angle out here. So this angle right here is an exterior angle. The angle adjacent to this angle would be this one right in here. It's the one that it shares, or it makes a linear pair with. That would be the adjacent angle. In this case, we're talking about non-adjacent angles. So the two angles that are not right next to it equals this outside one. And that makes sense because if these two are a linear pair, right? And we know these guys have to add to 180, right? These two are going to always be equal. So that's the logic behind it. There is formal proofs for this, but we're not going to go through that one today. So we have 2x plus 10 equals the sum of these two on the other side, x plus 6. So I'm going to subtract x from both sides. X plus 10 equals 65. Subtract 10 from both sides. X equals 55. So now I can find the measures of each of these. So this is 55 right here, degrees. And then 2 times 55 plus 10 down here. This guy is going to be 120 degrees. So this outside angle is going to equal the sum of those. So go ahead and try the last problem on your own and see how you can do it. Make sure you mark your figures, read the givens, and just mark them. It's not a proof. You just have to figure out the measures of the angles. All right, so this one we're given AB is perpendicular to BC. So this must be a right angle. So angle 2 equals 90 degrees. Next, these guys are parallel. Okay? So what type of angles are 1 and 120? They're on the inside, right? Are they on the same side of that line or on opposite sides? So these are same side interior, so they have to be supplementary. So if this is 120, this has to be 180 minus 120, or 60 degrees. So the measure of angle 1 equals 60 degrees. And then to figure out this angle right here, we have a couple different ways. If this is 120, we have a linear pair here. Right? So we know those two are supplementary. Or we can use alternate interior angles. And since those lines are parallel, we know alternate interior angles are equal. So those are 60 degrees. And whenever now I have the measure of two angles in a triangle, I can find the third by subtracting from 180. So the measure of angle 3 equals 180 minus 90 minus 60, or 30 degrees.